The human male secretes from 1.5 to 5 milliliters of semen in one ejaculation. About 60% of the semen is secreted from the seminal vesicles. Secretions from the prostate gland and Cowper's gland are also present. Less than 1% of the ejaculate is sperm cells, although that percent could represent as many as 500 million individual spermatozoa.
Are there controls on the production of sperm in the testes?
And how is that regulated?
Those are interesting questions. The exact details of the mechanism involved haven't been worked out yet. But it is thought that the controls are hormonal in nature.
As in testosterone?
That's one of them. And here are the others.
This looks complicated.
Actually, it's not that bad. There's a feedback mechanism involved. And you people have done feedback mechanisms before. Let's see if you can work this one out.
Well, let's start with what we know. Testosterone is secreted by the testes.
Right. The interstitial cells of the testes. But something has to stimulate these cells to secrete the testosterone.
Well, our choices are gonadotropin-releasing hormone, luteinizing hormone, inhibin, and follicle-stimulating hormone. Any suggestions?
Well, it can be GnRH.
Why not?
It's a releasing hormone. From what we've learned, releasing hormones are secreted by the hypothalamus.
Right, and they stimulate the pituitary to secrete their hormones. Gonadotropin would mean that the pituitary is stimulated to secrete hormones which affect the gonads, like the ovaries, or in this case, the testes.
So GnRH is secreted by the hypothalamus, which then stimulates the pituitary to secrete FSH and LH. How are we doing so far?
I like what I'm seeing. Now keep going.
Well, these two hormones must then stimulate the testes, but I'm not sure how.
Okay. LH stimulates the interstitial cells of the testes, causing the release of testosterone into the blood.
Then where does FSH fit in?
FSH stimulates the Sertoli cells of the seminiferous tubules. Simply put, the Sertoli cells nudge the spermatogonial cells to start producing sperm, provided testosterone is present.
So the higher the levels of testosterone in the blood, the greater the sperm production.
And the lower the levels, the lower the sperm production.
That's the idea, but it's not quite that simple. Because spermatogenesis is only one of the roles of testosterone in the body. Can you think of others?
The development of the male secondary sex characteristics, the building up of muscle mass in the body.
And testosterone has influence on male behavior and sex drive.
Right. So that's where the problem is. The body still needs the testosterone to perform its other functions. So how can you slow down the production of sperm without affecting the levels of testosterone?
Stop the production of FSH.
Well, we still have this one hormone, inhibin, left over.
Good. Keep going.
Well, FSH initiates sperm production in the testes, and this process continues when testosterone is present.
So as the number of sperm increases, they release our hormone inhibin into the blood.
This hormone then negatively feeds back to the pituitary, slowing down the production of FSH.
Which slows down the production of sperm, even though testosterone levels are still high.
Yes, that's it. Actually, there are two feedback mechanisms involved here. High levels of testosterone feed back negatively to the hypothalamus and the pituitary, regulating the production of luteinizing hormone. High levels of inhibin feed back negatively to the pituitary, controlling the production of FSH. Here's another look at it.
The control of testosterone levels in the blood involves the interaction of 3 different organs in the body: the hypothalamus, pituitary, and testes. For reasons yet to be determined, the events of puberty in the male are initiated when the hypothalamus begins to secrete gonadotropin-releasing hormone, or GnRH, into the portal system connecting the hypothalamus with the pituitary gland. This hormone stimulates the pituitary to increase its secretion of 2 different hormones, LH, or luteinizing hormone, and follicle-stimulating hormone, FSH. LH stimulates the interstitial cells in the testes to secrete the hormone testosterone. Testosterone has many effects in the body, one of which is the development of sperm in the testes. High levels of testosterone inhibit the secretion of GnRH from the hypothalamus and LH from the pituitary gland. This action results in the lowering of testosterone levels in the blood. As a result of this feedback mechanism, the levels of testosterone in the blood remain relatively constant. A second feedback mechanism is related to the production of sperm in the testes. FSH, released from the pituitary gland, stimulates the production of sperm in the testes. FSH and testosterone are both required for the proper development of sperm. As sperm production rises, the Sertoli cells of the seminiferous tubules release a hormone, inhibin. This hormone inhibits the secretion of FSH from the pituitary gland, and in effect decreases the sperm-producing activities of the testes without affecting the levels of testosterone in the blood.